I think still people are yet to join. Let me pause the recording for a while. All right. Okay. So let's go there. So let's try to see where we are. We frequently have to visit so that we don't forget the previous topics. So overall, entire thing we should have in our brain, like right. So we started with basics, Linux basics, which is very much fundamental for everyone. Linux basics, even like if MS DOS also can also be covered. Um, Afterwards, we as a DevOps engineers, one of the programming languages, important programming that we felt that is the industrial wide use when it comes to DevOps engineer is Python. And then we actually we started touching into the DevOps tools, and for that, yeah. So we also discussed about Git. Git we actually use every day, but though we use every day, we use only few of the few frequently used commands only. So we actually discussed about the architecture of Git control, how it works, actually how it evolved, when it was started, and Docker. So this is the point where actually the real um, uh, tools of DevOps came into picture. So Docker, we had a very good discussion on Docker, and we covered few important topics of Docker. Almost many topics. We had hands-on Docker. We played with it, right? So I think people are comfortable with Docker right now. And afterwards, then comes like how to handle our repository, how to handle our day-to-day commits and so on. For that, we used CI/CD tool, and from there we covered few important CI/CD tools. That is, we started with Travis, and then we actually moved to Jenkins. So we iterated to Jenkins more once and again, because it is a very open it is a open source tool and widely accepted. We can do a lot of it. Is very highly powerful and very easily useful. So we covered Jenkins, and then we move to configuration management tool, that Ansible. We felt it also very important, and I think I think we covered most of the topics. We successfully executed that. We implemented all of them, all of the most of the concepts of Ansible actually. So uh, we covered yeah, so we covered most of the topics in Ansible, like Ansible models, Ansible ad hoc commands. Yeah, so here Ansible ad hoc commands. So what is the playbook in Ansible? What is the ad hoc command in Ansible? Inventory. What is inventory management? How do we inventory? How to do inventory management, configuration management? And also we touched roles also, right? So almost we covered everything, and then later we thought of like we'll cover K8 cluster implementation using Ansible also, right? Yeah. So parallelly also we also had we also tried to actually implement in Azure wherever feasible. I think I shared a few sessions of how to run Ansible in Azure cloud as well. So that will actually make us confident in like saying that we can run Ansible in any of the cloud machines, whether it is AWS, GCP, or Azure. We can do that. The concept, we need to actually remember the concept, not only concept, like whenever we have to practically implement them, so that uh, it will be in our we can actually showcase our skill set only if we are actually practically able to implement it, right? And we'll gain confidence only when we actually implement them. So um, so we touched configuration management. Now we will quickly go through these two things, roles and Ansible vaults. We had a quick overview of roles. So, so let's again rediscuss about what roles is. So we have a very fine recordings of roles, Ansible roles also by Ashok Singh. We can actually visit that. I think it's in part 4. I think so. It's in part 4. We can visit that. Okay. So just keep in mind. saying that if you have covered till now, practically implemented till now, all the concepts of Ansible, then roles is nothing but it is to the next level to solve the problem to the next level. Um, Next level in the sense like when your code, generally when you go on coding, then your code becomes very big, right? So it becomes very hard to manage. It becomes very hard to manage. So the same case comes here with Ansible also. So you, for every task, you actually write Ansible playbook, and playbook, as you go on adding new functionalities, the playbook goes on increasing. So people thought like Ansible is a open source code. So there is a community open source. There is a community who is actually actively contributing in Ansible, a very mature community, right, actually. So they thought that why don't we actually train people to write Ansible code in a very well formatted way. Okay, so that's where the role comes into picture. So the roles is nothing but it's also like a way of writing Ansible playbook. That's it, nothing else. So you can write Ansible playbook. How do you write Ansible playbook? You generally write Ansible playbook in YML, right? So general YML. Let me show you one typical example. Last session, as we had discussed, like Flask app, simple Flask app, and so on, right? So mm, so few playbooks are already there. So here last we started with this particular YML, right? So this YML is covers lot of concepts of Ansible. So we were able to successfully execute this Ansible, right? So but in industries, right? So when it comes to when it comes to industries, right? The playbook actually grows to very huge level, right? So people go on writing code, adding a lot of code. So if you write a single code in the same single file, right, it becomes a little bit difficult to understand. The guy who has written the code can understand it, but it um, only like when you actually work as a team, when you work in a particular team in a company, then there are a lot of people who want to actually who have to work on the same uh, uh, business, right? So they have to work on the same code that you have written. So you should write in a code such that it should be easily understandable by everyone. So everyone has to follow one particular pattern so that they can easily understand. So better to divide all the variables in a separate file. Better to divide the task, put the task in a separate file, right? So they if there is a one particular syntax, if you follow one particular syntax, right, then you divide the one big chunk of big file, which big chunk of code, into multiple small files. Then you know that by looking into the file name, you can actually say, oh, okay, this is only for variables. Okay, this is only for tasks, and so on, right? So that makes sense. People will easily able to understand the logic. Okay, so that is the main concept of no, that is the main concept of roles. Okay, so let me explain. Let me show you. So our Ansible open source community came with a role saying that, okay, so when the code becomes Ansible code, your YML becomes very big and it becomes hard to manage. Better you follow a particular syntax. So the syntax is like they have divided the entire playbook, entire functionalities of Ansible playbook into multiple subdirectories. So basically, they have divided categorize them into eight eight main subdirectories. So that is what Ansible playbook, Ansible roles is about. Like, let me go to the particular slide. I'm trying to open that particular slide for which shows the structure of roles. Yeah. So it's nothing complicated as of such. It's a way of educating people um, to follow a particular single syntax, a single way of structuring the entire code base, so that it will be easily and manageable, easily understandable. So actually, they divided saying that, okay, let's divide the whole functionalities into eight subdirectories. So defaults, wheres, tasks, files, templates, meta, handlers. So this is what they have structured. You need not actually specifically follow this particular syntax, but but um, but if a single pattern is followed, then you need not actually explain some other person. He You can just say that I am following the Ansible role syntax. Then they will understand because it is there, well documented. You can just go into Google and say that what is Ansible role, what is its format. Then Ansible documentation, Ansible official documentation will say you what is the structure of a particular role. So this is what they have officially mentioned it. So everybody follows the same syntax. So it is easy to understand. That's it. Okay.
Anil, just a
Yeah.
clarification. So this Ansible is related to the configuration management tool, correct?
Yes. Yes.
So
Yes.
that
Yeah.
under that the roles uh, management will come.
So if it is so that's what like you need not follow the rules, but uh, so basically, if your Ansible code that you have written becomes very big, right? So then it is better to follow the role syntax. Like if you have written a very big playbook, then they actually recommend saying that okay, divide the playbook in such a way that it's understandable to everyone. For example, a playbook contains many variables. In Ansible, you can actually have a variable, and variable can have a default name, and the same variable can be actually have uh, predefined some predefined based upon the category that you are deploying. Like for production, the variable will be different. Uh, for for test environment, the variable will be different. So how are you going to handle it? So in that case, so basically, like for example, so for production, you want to have a different variable name. For testing, you want to have a different variable name. By default, variable name should be different. By default, if you don't give any value, what is the default value of the variable? How do you define? So they have structured in that way. So here saying that okay, so there is a defaults directory. You just create a default directory. Inside that, inside that your YML main.yml will contain variable names. So that variable names contains that variable contains default values. So if the variable is not initialized at all, this the value that you have defined in this default directory will be taken into consideration. Okay. That's how actually they say. Like for example, there is a test
So
directory.
these and all it will come under some plugin. I mean Ansible plugin, correct?
Yeah, no, it's not Ansible plugin. So basically, when you say roles, there is a specific keyword, so it's dash role, and you just say the role name. That's it, and it actually works. So, uh, so,
Okay, so
so,
it
so,
will be in the Ansible window.
yes, it is all about structuring the data. That's it.
Okay.
It's all about structuring the data. Basically, like suppose you have only functional when you write a programming language also, right? So similar functionalities will be actually clubbed together in one place, right? So similarly, like in Ansible role also, they club similar functionality in a single place. For example, tasks. So task is the main part. It's the main part of the entire role. So task, whenever you actually perform Ansible, when you run Ansible, basically you are running a set of tasks, right? So people, Ansible role structure says that whatever task you want to execute, all the list of all tasks should be there inside this folder tasks. It should be there inside the folder task. So it's just restructuring. So you might, so it's like a mandatory thing. Task is definitely a mandatory thing. So in that, whatever in the main.yml, whatever you write, it there are nothing but list of all tasks. Is uh, you define a specific variable name. So those variable names will be there. If you are actually defining the variable names, they will be under where's main.yml. You define the variable names in the main.yml. If you have some 10 variables defined, 10 variables you want to define, but in main.yml or under where's directory, you define only 5 variables. and you haven't defined the other five variables. So it has to take some default values, right? So default values, those default values which you haven't defined can be there in the inside default mains.yml. So that is what uh, that's what this structure is. So this structure actually they follow because it will be easy for us to maintain. Like if you can see in industries like in big industries, when many people write code, the 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 YML becomes very huge. So this is the structure they actually follow. Based on this structure, it's not only like they say you explicitly to follow this particular structure. You need not actually follow the structure, but they actually created a live repository of roles. Actually, someone from open source Ansible open source community has worked very hard on one particular domain. For example, nginx deployment. He identified hundreds and thousands of cases, not thousands, maybe hundreds and two hundreds of cases, right? So what if, like, if you want to have deploy nginx in this particular port, what you need to do to actually configure nginx as a gateway. You understand, right? What nginx can do. Nginx can be acted as a reverse proxy, can also become a reverse proxy. It can also become a load balancer. It can also become an API gateway which actually routes to different ports. Okay, so engineers can be configured in many ways, right? So when it comes to so many cases, right, uh, you can actually if you can configure nginx in so many ways, right, it has lot of ifs and else conditions, right? So all those conditions, if you club them together, you have to arrange them in a well formatted way. So somebody like written a very matured code following this particular directory structure and uploaded in an open source community called Ansible Galaxy. So he has spent like 2-3 years on it to develop the entire Ansible code and a well formatted way. So why do you want to reinvent the wheel? All you need to do is like go to Armada. Sorry, you go to Ansible community. That is Ansible Galaxy. Okay. So Ansible Galaxy is a community which contains all the roles which can be easily downloadable. So okay, so for Nginx, I think it comes under this particular category web. So you can just search for Nginx. For example, just for example, there are many other things we cannot. We are not experts in anything. Even the guy who has written the whole Nginx might have taken a lot of time, like years. He might have spent years. Maybe like many people have contributed on it, right? So he actually wrote the code in a well formatted way. All you need to do is like download this particular role. You just need to install this code. Once you say this, they have provided a particular command line tool called Ansible Galaxy, and you just need to download this particular role. So just copy it. For example, I will do. Oh, okay. I need to install Ansible. I think I already installed. I have already there. Um, yeah. So I have something here. So all you need to do is like install Ansible in your machine, and then from there you just reuse the code. You need not actually write the whole playbook again and again. You just need to download this particular uh, uh, Ansible role and use it as modify it according to your needs. So suppose you also want to implement all the features that he has already done, then you need not rewrite the code. You just need to understand the syntax of saying that once you install it, right, you can see the structure. um, I'll try to log in now. 1 second. So mhm. So CentOS is already running, right? Yep. Yep. So I will try to actually download one particular Galaxy. Okay. So it is CentOS user. So here I'm in CentOS. Then let me see if I can run Galaxy. Okay, so I have to go into virtual environment. So this is a command to actually go into a virtual environment. You know this command, right? Sybil. Okay, so this is how this is how the Ansible Galaxy works. Now let's see how to run this. So you just need to run it like this. Now it is downloading. It is downloading the entire role of Ansible Galaxy into your machine. Okay, so that's what. So it goes into one particular directory. I think did it come here? It comes into one particular directory actually. So it actually goes into because we are running in a virtual environment. It creates a virtual directory um, called let me see minus a. Okay, so that I actually uh, downloaded a lot of code actually, so it's difficult to understand. So this is the problem when you have a lot of YMLs, right? So then it actually becomes difficult to understand. Ansible, yeah. So here we have roles. So here we have downloaded this Galaxy here. So let's go. Okay. So it actually see this also follows this particular syntax, same syntax, defaults, handlers. So you haven't written the code. You have downloaded it from Ansible Galaxy, right? So you can see that they follow a simple syntax. Now you can understand saying that okay. So you have if you have a default variables, so what are the default values of a particular variable? Then you can just go to default default and just go open main.yml. Sorry, vi here open. So now you can see there are a lot of variables here. Default values of nginx default release is empty. nginx y yum repo enabled is true. nginx ppu is a false. So these are all the default values. These are all the default values that you have to write. Okay. So this is the code you haven't written. Somebody has written it. So it is lot of variables will be there. I think so. So these are all the variables that they have defined. They are different values, and somewhere where they feel like you might want to enable something. In this case, for example, they want to have extra HTTP options. If you want to enable for your Nginx, what you just need to they have provided a way. You just need to uncomment it, then those features will be created. So you so by just uncommenting saying you have that particular functionality enabled. Okay. So this is a very huge file. We can't actually execute. Just I'm trying to understand, trying to explain you the basic structure. So Nginx, you see that this is a very big project that they have executed. So let's suppose we will go out. We will go to tasks. Suppose then if I see in the task, we will also be having one main.xml for sure. Main.yml, main.yml will be there, and there are sub YMLs. Looks like you can see that they have written the playbook based upon the operating system. Like for Debian, they have written Debian for FreeBSD, for OpenBSD, for Red Hat, and so on. I think in mainword YML, they based upon the OS, they actually call the appropriate YML. So we can just see main.yml, and from here, so they have this, right? See, first they identify the Ansible family. If the Ansible OS family belongs to Red Hat, then they invoke setup Red Hat YML. If its distribution is Ubuntu, then they include this task. If it is Debian, then this task. So they have very neatly covered all the operating systems. So it is a very generic thing. So it's very useful. So you can just go and download it and use it. And probably like they will provide a fine README also. We can actually read that and try to understand. Um, so so README is also there. So we can actually open the README and see. Maybe here also we will see any. There will be proper. Yeah. So README is there here. So you can just follow these steps, and they will explain what it does. How do you actually use this particular role? They'll provide you a proper way of how to do it. So you by studying this, you can just quickly get started with your business requirement. So if you have a requirement of configuring a engineering server, then you can opt for a Ansible playbook with this particular role. This role, you can actually download this particular role and try to read the documentation and get it done. So this is well matured code being which is pushed up, but try to download only those roles which have been got good reviews, which have been active recently, been very active, which have got lot of downloads. Try to work on those roles only. So these roles, for example, it has got so many downloads because so you can actually judge that this is being used. This is working very stably. So you can go with this role, but you might not be interested with roles which are like 47. Maybe you can try, but which is only 510, you may not want to take the risk of trying to execute them. Okay. Yeah, try to, before getting into the roles, try to become expert in writing a simple simple Ansible playbook, and try to understand the syntax. Try to understand what are the basic core concept. Roles is an advanced concept. Once you know how to write a playbook, how to how what is inventory, how to manage inventory in Ansible, how to run ad hoc commands in Ansible. If you know all of them, then you might want to come into roles, right? So um, so then you might want to, then you will be getting comfortable saying that, okay, I want to use a particular role. I don't want to reinvent the wheel. I just want to execute already well stable Ansible roles. Okay. So here in our slides, we have already explained a way of writing a role. So here, if you see, one thing you need to remember that each and every directory should contain a main.yml. Okay, main.yml is there. Other YMLs can be there, but main.yml should be there. And each directory has one specific purpose, as I have already mentioned. So files are related to files. So if you want to copy some files into your into a remote machine where you are actually configuring, which you are configuring, you put them in files directory. Similarly, so you generally they prefer to write a README, and some tests. If you want to write some preliminary test, then you probably want to write it in tests or test directory. So that is what the structure of role is meant for. Okay, so we can actually create our own roles. We can create our own roles. So this is an example of downloading, which I have already shown you how to download it. It finally shows what uh, what are you trying to roll, what role are you trying to download, and where it is downloading from, and whether it is installed successfully or not. So we also identify that once you downloaded it, right, you have to identify where exactly it goes. So it does not blindly dump it into the current directory. It actually downloads into one specific directory. Okay, so that give me 1 minute. 1 minute, I'll come back. Okay. Yep. So sorry for the interruption. So this is basically like for advanced uh, implementation for a better maintenance purpose. We use rule. Okay. So so here, for example, this is what you can actually create a simple role. In our role, as I mentioned, tasks. Task is one important directory which definitely needs to be it needs to be created, and that main.yml should contain at least one task in it. Other than that, um, other directories may be optional. It may be optional. For example, I have another role created. So here, Ansible deploy. This is one of the role structure I have created. But I didn't define all the directories. For example, I have created this directory. I have created only tasks and templates, only two directories. I did not implement all the 8 directories. I can just define only 2 directories. Um, so other directories are options, but tasks is one of the directories which which is definitely there everywhere. So here, this is one structure which I have implemented in my company, right? So just wanted to explain. So here you can see that data service, GeoServer. These are different playbook roles. You can see that these are different roles, and when you go inside this particular role, you can say that it follows a particular directory structure. Here we have two tasks and templates for this particular role, GeoServer role. For CUDA role, we have we don't have a template. We have tasks and VARs only, so on. So task looks like mandatory for everyone, and other directories on need basis we can just add them. So you can assume that in this particular role, for example, there is no VARs directory, right? So we are not using at all. We are not using VARs at all. We have predefined tasks only, but we don't have any specific variables. We which is which changes. Okay. Yeah. So so we have covered a lot of things. Ansible role is one of the important topic, but this is advanced topic. It is enough to actually understand what we need to what we can do using Ansible role. We can actually download a pre-existing roles from open source, and we can just understand it from the syntax, or we can write our own role based upon the syntax, based upon the format. Okay. Yeah. So our um, slides contain a simple example here. You can just try to run this. It should not be difficult. You can just try to run this particular role. You can just define a role here. Here we are creating a role called nginx, and we are copying it to an YML install nginx. And all we need to do is like run this particular run this as a playbook. Simple playbook. So this particular playbook is using a role called NGI NX NGX, which we have actually downloaded using Ansible Galaxy. So Ansible Galaxy, we have downloaded this particular playbook and we are running this particular role NGI NX, which you have downloaded. Uh, so the playbook knows that where to pick the roles from. It will automatically go to that downloaded role and it will execute that particular role. Okay. Yeah. So just follow these slides. It should not be difficult I would actually encourage you to actually use some of the roles um, from Galaxy. So you can actually try to run uh, Ansible Galaxy and try to download one particular role and try to play with it. Yep. So let's move to next important topics, other important topics. So we also need to understand that we have something called Ansible Vault. So it is a very simple topic, but it is very important when it comes to security. So if you want to hide your playbook. You have written a playbook and you want to hide it, and only on need basis you want to open it, right? So then the solution is Ansible Vault. So the Ansible Vault is a way to actually so basically encrypt your YML files, right? So using this Ansible Vault feature, you can actually encrypt your YML file, you can decrypt your YML file, you can create a create new vault encrypted files. So they are all are simple one-line commands. So imagine you are creating a lot of Ansible playbooks. You are already having playbooks. So all you need to do is like you just need to use Ansible Vault command to encrypt that particular playbook that you have written. So your playbook is so here in this example, flask app.yml. Flask.yml, you just need to encrypt it. So in this case, right, you have this particular command Ansible Vault, and you say Ansible Vault encrypt, and then it will actually prompt for a password. Uh, so you just have to enter a password that you can actually remember, and your YML will be encrypted. And when you actually open this particular YML letter, you will find out that it is not in a readable format. It is encrypted. So if you want to decrypt the YML again, you just need to execute Ansible Vault, decrypt the YML. So by doing this again, the decryption will be successful, and it will be back in a text format. So this is the text format. Uh, it will just run it will just encrypt and decrypt. So this is a very important feature that you can actually use. You can actually propose to your team members or your clients if you want to secure your playbook. Okay. Yep. So these are the commands for Ansible Vault we can actually try. So it's pretty straightforward syntax. You can just Ansible Vault create, Ansible Vault decrypt, Ansible Vault. If you want to edit it, Ansible Vault edit. So if it is a encrypted file, if you want to say Ansible Vault edit, then it will actually prompt you for a password. Then you need to enter your password, and it will open the YML for you to edit. If you are not able to enter the password, that means you are not authorized to open the playbook and edit it. Yep. So this is a quick description about Ansible Vault and Ansible roles. So other concepts we have already covered. We have covered a lot of other topics we have hands-on. So I would actually say that please put your hands-on roles and Ansible Vault. It should be pretty straightforward. Okay. So these slides actually contain the exact commands that you can actually just try it out. Okay, so these commands actually helps you to actually run on Ansible roles. Just need to copy paste. Just need to copy paste and see how it works. Okay. Yep. Okay. So let's move to the next topic then. Next topic. So Kubernetes. So we here in our Ansible topics, we have the final topic in part 5. We have entire description of how we can actually deploy Kubernetes using Ansible. Okay, so before trying to do that, I think we can have a quick understanding on what Kubernetes is. What exactly is Kubernetes? Okay, so you guys know what is Kubernetes is basically orchestration tool. So we'll try to explain completely about Kubernetes in a separate session uh, in the probably in next week. Uh, but before trying to execute Ansible in Kubernetes, we have to understand what exactly we are doing. What is Kubernetes, at least to the higher level. Okay. Um, so as you know, Ansible is basically a configuration management tool which helps you to deploy, which helps. So in simple normal person terms, it helps you to install software. It helps you to configure software, right? It is a configuration tool. It helps you to configure a software. A software can be configured in different ways, right? So Ansible helps you to configure. I want um, for example, I already discussed many times, right? The Nginx, I want to configure Nginx as a load balancer, right? So you can do that. You can actually do that. Actually. Okay. So but uh, so what is Kubernetes then? What is Kubernetes? So basically, Kubernetes is also a orchestration tool which does the task of a human DevOps engineer in simple terms. So what do you mean by orchestration tool? So orchestration tool is means that if you actually if you actually implement a Kubernetes solution, then you can assume that it will take care of the health of the machines by its own. You need not 24 by 7 monitor it. You almost like 90% 99% of the task you actually configure it. You actually say give it to Kubernetes, and Kubernetes will handle it uh, by itself. So for example, let's say that in a production machine, you have a particular web application. You have a web application and you want to make sure that this particular web application is always up. It should never go down. Suppose that's what you want to happen, right? So in case there is no such orchestration tool, what you will do is basically you 24/7 you have to make sure that the machine is up, the power is on, right? The power is on, the machines are up, and there are multiple replicas of the machine. Sorry, multiple replicas of your web application. Suppose your web application is a front-end web server. Okay, so you have written a web application. Your team has basically written a web application, um, front-end web application on React or maybe Angular JS and so on. So basically, it's a front-end code running on a web server, right? So and people will be actually accessing it via some domain, right? For example, www.mywebsite.com. When they go to www.mywebsite.com, so basically what happens is like that mywebsite.com is a domain will be resolved to if it is my.com, it will result to some particular port number. Default port number is for HTTP is 443. By default, non-HTTP it is 80 port, right? So your request will go to port number 80 or 443. There, your web application should be running. Either one web application, or if it is running on a load balancer, then multiple web applications might be running in the behind, and your load balancer will be diverting a request to one of the web application. What if one of the web application is down? How are you going to bring it up? How will you bring your web application up? So manually you have to see that your web application is up or down or not, right? You are all Suppose you have three web applications running, all the three applications should be working fine or not. So you have to take care of it. All these things are done by Kubernetes. Okay, so this is done by Kubernetes. So how the Kubernetes works, uh, um, the complete details of how Kubernetes works, we'll explain next session. For now, we will assume that Kubernetes, in order to in order for Kubernetes to work, basically Kubernetes has two main parts actually. Let's say it has two main parts. One is like master, and the one is worker. Okay, so we can say that Kubernetes works on two main categories. What we can actually say in simple terms? We can say that Kubernetes works on two main categories: master and worker. Okay, master is responsible for taking care that um, it provides all the environment required for a worker to run. So, like if it monitors all the workers. Okay, so it monitors all the workers where the application is running. The customer application, web application, written in React, all those whether it is a backend database or whether it is a business backend API server, API server, REST API server, all these will be running on worker machines. All these worker machines. So there will be a lot of worker machines, right? Worker machines, and this master will be continuously monitoring all these worker machines. This master's responsibility is make sure that uh, all the health of all the worker machines, the number of worker machines which are supposed to be running. There are different factors like the disk space usage, RAM space usage, the CPU usage uh, is being uh, is in a very healthy state. It is not crossing limits, or um, it is not getting down. So all these things are being taken care of master. So basically, Kubernetes is nothing but a basically a master machines and worker machines. So we need to, when we say that we want to deploy Kubernetes, basically we deploy master machines and worker machines, right? So we want to deploy this worker machines and master machines using some, either manually we can do that or using some tool. So here we are trying to do the same deployment of Kubernetes cluster using Ansible. So using Ansible, you can just deploy your Kubernetes master and workers. Okay, so that's what we are trying to do. So in this particular video, part 5, we are trying to come up with an approach how we can actually deploy a a typical Kubernetes cluster. Okay, so cluster is nothing but cluster is a group of machines where masters are running and clusters clients are running, workers are running. Okay, so this clients sorry, masters and workers together form a Kubernetes cluster. Okay, it's a group of machines. Okay, so now how how can you actually, we are going to show how can you actually deploy a Kubernetes cluster using an Ansible configuration tool. So for Ansible, it is nothing but a software that needs to be configured, right? So all we need to do is like write a playbook which follows some set of instructions which are required to deploy Kubernetes cluster. So that's what we have done this particular video session. Part 5 actually explains those steps. Okay. So this will be very much understandable if you know about Kubernetes. So Kubernetes is a very vast topic, and in order to maintain huge Kubernetes Kubernetes, like there is this is a very big business like IBM, Microsoft, Microsoft, Azure, um, Google, or actually have their own services called Kubernetes services, IKS, EKS, AKS. So they are not, they are Kubernetes solutions that they are providing. Okay. And internally, they are also, most of them are actually using Ansible to actually maintain their Kubernetes solution. So Ansible is a very powerful tool which helps them in maintaining a Kubernetes solution. We'll come across the later. So I think let's assume that we know about Kubernetes. Our task is to deploy a Kubernetes cluster, which basically is a group of masters and workers. Okay, so that's what we are trying to do. So that goal we are trying to achieve it right now. Okay, So for that we have written a simple um, a simple repo which handles which handles this deployment. So it's basically there in our slideshow. Your slide, you can actually see. I think it's in the end of it. Yeah. So no, not this one. It's GANs. And so deploying Kubernetes cluster. So it's there somewhere in the slide. We have that actually. So we can actually refer to that particular code. No, it's told. I think. Yeah, it's there here only. Okay, so I'll just show you the code actually. Kubernetes, Ansible, AWS. This code, it's there in our slide also somewhere. We can actually refer to it. Okay. So this actually, if you are able to understand this particular Kubernetes Ansible deployment, if you are able to do this right, so then we can have a complete understanding of how powerful is Ansible, how we can actually automate things without having any manual intervention. So I will actually explain you step by step. Here, I'll try to cover most of the code actually. Okay. So let's start from this. Now let's assume that we know Kubernetes. Okay, we know Kubernetes. So basically, we are having a task of deploying Kubernetes masters and Kubernetes workers. Okay, so we have two things to do. So if you remember, we already have written ec2.yml, right? So this we already have written it, right? So as a first during the first session of Ansible, we were able to create multiple AWS instances, right? So using this, right? So what steps? Let's try to recollect what we have done. We created, we used EC2 module. We used EC2 module, and we have created two instances of EC2, and we created EC2 instances using this particular key pair, which are there in the vars folder. And we have used the key pair, instance type, image ID, reason. We filled this according to our needs, and we run this particular ec2.yml. When we run the ec2.yml, we were able to create instance. We were able to create instances here, right? So we could actually see that there was one bastion instance, and we were able to create two um, two other instances, right? So that example we have seen. Now we will use the same uh, same playbook, but little bit modified. Okay, so that one we will create ec2k8.yml. So we have the proper steps already there here. Okay, so if you remember, these are all the steps we have already followed in the previous sessions. So it took a lot of time to actually run all these steps, right? So this actually uh, installs the Ansible in your machine. It installs Ansible in your machine, and then you create a virtual environment. That's what I already did now also. And then um, we actually install few softwares, like if you remember those softwares like Boto 3. So those we actually installed using this command. So required, yeah, I will show you the requirement.txt. Um, yeah. So Boto 3 and Ansible. So these will be automatically installed by running pip install requirement.txt, and then later we'll configure the AWS. We'll export a AWS key. It can be done via an AWS configure or via AWS key. So these all steps are already followed. You can just see the previous recordings that we discussed in the last week, right? So these steps we will actually do the same steps again, and we will be able to configure our machine. Okay, so by configuring, by running this command, these commands, right? So create infra.yml, by running create infra.yml, we will be able to create machines, which is almost same like ec2.yml. Okay, so let's see what create.yml is. So it's a some extra task along with normal EC2 installation. Here we actually finally divided into two parts. Basically, master deployment. This is master deployment, launch master instance, and this is worker deployment, launch node instance. Okay, so we are trying to here we are trying to in this case we are trying to create two EC2 machines, virtual machines. So we are trying to create node instance, and we are trying to create master instance. So these are the two things that we are trying to do. And also we are trying to automate as much as possible, so that if you remember, like we are creating our own key using SSH keygen, right? We create our own key SSH keygen, and then we copy that particular SSH keygen to the other machines and so on, right? That SSH keygen that we have already created, that we create using terminal, that we are adding in the playbook. So you can imagine the power of it, right? So imagine that you are doing this step by step in your machine. Instead of that, you just run this particular create infra.yml, and it will actually automatically execute this particular first task. This first task is actually generate a key. It will just execute a SSH keygen, and copy it in. It will create it in ID RSA, the public and private key, and we are actually using few many models. So we have covered Ansible modules, right? So here you can see that we are using shell module, EC2 key module, EC2 module. So these are the different models we are already using, EC2 module, and so on. Right. So here we are using these models for using shell model. We are generating the key for EC2 key module. Uh, EC2 key module. What we are doing is like we are a uh, assigning a particular PM key, a PM key that we are that we have that we have created here. So that key, sorry. So we are creating a new name. We are creating a new name, DevOps, a key, which will be nothing but the new uh, public key that we are creating using SSH keygen. I hope you understand what I'm saying. Okay. So imagine that manually you are creating SSH keygen in the terminal. This command you executed. So what it will do is like it will actually generate private key and public key, both, right? So it will create private key and public key, and that key will be assigned as a PM file, as a key file for the new EC2 instance that you are you are creating. So here you are creating one instance, right? You are creating one instance in EC2 with key name key pair, right? And another instance you are actually creating here using key pair. Along with that, this key pair is nothing but the key pair that you are using to connect, log into your machine, and and parallelly you are creating a separate key pair called DevOps, which is nothing but your own key that you have that you are creating using SSH keygen, and that DevOps key will be used to authenticate later. Okay, so you need not worry about like this code is available public. You can actually look into this particular code. You can look into this code. So and that particular key that you are creating in DevOps, right? The DevOps key will be used in the next playbook. So this is the second playbook, distribute.key.yml. If you see clearly, right? So the key that you have created is nothing but DevOps. So that DevOps is nothing but IDS space a PR, ID RSA pub, right? So that pub will be mapped with this name, DevOps.pub, DevOps.pub, which will be copied to the uh, new machines that you have created, the two machines that you have created that will be copied to the authorized keys. So that we can automatically log in to the remote machines, those two remote machines. Okay. So the steps are very clearly mentioned here. You can actually just execute these steps one by one, and you can see how it works. So for example, let's go and I'm just trying to explain you step by step the code so that we can understand what we are actually executing. Okay. So for example, I will execute this particular YML file now. Let's quickly start from scratch actually. Okay. Let me, what shall I do? Let me um, delete them. I'll delete all of them. Okay. So from where shall we start? So let's start from in the CentOS machine. So I'll start a new CentOS machine. I'll call it as Bastion. Okay, because we don't have any Bastion for now. So we'll start from Bastion. I have faced a new problem now with the AWS machines. CentOS machines, sometimes the machines that I'm going to create are not able to install yum. Um, I hope that will not come again now, at least. Let's see. Let's see. Let me select this. I hope the problem will not come in this machine at least. I will try to create a CentOS machine now. So I already, we have already did this many times, right? So similarly, we are doing now. T2 micro, we are trying to create a Bastion keyword. So shall I delete these files? I'll try to delete. How can I delete them? There should be some place to actually delete key pairs, right? There are a lot of key pairs. So somewhere here, I remember I was able to key pairs. Okay, yeah. So here we have key pairs. So if you want to just delete them, you can just delete like this. So DevOps, if you remember, DevOps is what I have tried before. So it automatically created a key pair uh, called DevOps. So that's what I was trying to explain. So this key pair was automatically created by code by the module EC2 key. So if you see here, um, in our EC2 key 8.yml, sorry, EC2 key 8.yml, create infra, yeah, create infra.yml. You are creating here, generating a key pair and assigning it to our AWS key pair value using this particular command. So here you are saying that I want to create another key pair DevOps with this value ID RSA publicly that you have generated from SSH keygen. Okay, and then it will come. It will be attached to our AWS services key pair list by this module EC2 key. So that's what we are doing here. And because of this, because this command executed, because this command executed successfully, here we are able to see a new key pair called DevOps here. So that's what it happened. Okay, let me delete it. So to confirm deletion, type delete. Okay. So let me clean every machine. I'll only keep Bastion. Only one key I'll create. Keep with me. And now I'll try to create instances. So there are no instances running. I'll just create another instance now. I'll create a Bastion instance. I'll create an CentOS 8. Okay, CentOS 8. Selected the CentOS 8 is a free tier. Okay, I'll just execute it. So it is saying T2 larger. Let me make it T2 micro. And as a existing key pair, Bastion key pair, I'm going to create Bastion key pair and then launch instance. Okay, so successfully I have launched a created instance. Now I'll try to connect to that machine. It will take some time to actually launch. It is still not coming as a running state. It will take some time. Mhm. Yep, so it's in running state now. Now I can actually connect to the machine by clicking on disconnect. Here I'll get the uh, example way. Our machine user is CentOS, right? So you can see that by seeing this CentOS, right? So you can actually connect using CentOS. So though example is root at the rate something, you have to modify it to CentOS. So I just connect. Okay. So I will try to connect to that machine using CentOS user. It's not root user. I will modify it to CentOS user. And why? Bastion. Okay, now it worked. Okay, so oh, permission denied. Okay. Oh, why? Siege mode. Mhm, mhm. Why? Okay, this is interesting. It never happened before. I created batch machine, and to connect, I have to use this command. Yeah, I just need to use this command. And because it is CentOS, I have to create CentOS. Permission denied. Wow, is my key corrupt? Maybe my key is corrupt. Oh, this is weird.
Anil, for this instance running, any
Huh.
charges there in AWS?
Yeah.
Any?
If it is running for, so when we launched the instance, right, it will say you the charges actually. So it is free tier, but if you run for long time, it will start. If you keep your machine on,
Mhm.
then it will charge you. So suppose you selected this, na? So here they actually say it's free tier, and it will charge you $0.386 per hour. So this is what they are charging.
Oh, 0.386.
Yep.
No, any free time is there, or it's from starting itself? This is charge.
Yeah. So starting itself, they have mentioned it like if it is hosted on uh,
Okay.
T2X large, then they'll charge you this much.
Mhm.
Yeah. Mm, So if you turn it off, then they will not charge you. But if it is on for, then they will actually charge you per hour basis. Okay, so it's something weird happened. I have configured it properly. It never happened to me. So I am not able to log into this new instance. I actually use the same instance now, and they actually say this to connect. This is the command we need to follow. Yeah, sorry. CentOS. Okay, I think my bastion.pm is corrupt. So let me drop this and create a new instance, new thing. So in the last sessions, we never faced this problem. Not sure why. So I'll try to create. I used this only right before also, or this one. Free test standard contract. Too small. It doesn't matter actually. So as long as the PM file is good, it should work fine. Now it is CentOS 8 is losing a lot of support actually. So let's select this. Let's say it should be x86, right? Okay, so it is x86 64. Hope this works. Let's see. I will create a new pair now. I'll create a new pair called new Bastion. New Bastion. Okay. PM file. I'll create it now. So new Bastion, I downloaded it now. So go to this particular folder. So new bastion.pm. I'll copy it to my current directory. Okay. Okay. So this is the new PM file. First of all, I have to make. Let me launch. Let me launch the instance. Uh, oh, did I? Is it SSH enabled? Let me check that. Maybe like it is. It was not SSH enabled. Okay, I terminated the previous one. Let's see this. Let it happen. So we have done it many times, right? We never faced this problem. Somehow today I'm not able to log in. Okay, it is still starting. Okay, somehow it is taking long time. So let's see the security group. This is the security group I am using. Inbound rules, and it has SSH enabled. So I should be able to access it for sure. Hmm. But somehow I'm not able to access. Okay, now let me try this. User is CentOS. Yeah. Okay, it should work. Mhm. I did chmod. Okay. Mhm. Yeah. So not sure. Okay. So I logged into the machine now. So this is what the machine I logged in. So I will modify it to root user sudo dash. Now I'm logged in as root. Now let me actually follow the steps. Now come to the Kubernetes cluster machine. Here I will try to clone. So before cloning, actually I need to install Git. Uh, it is CentOS. So yum update should work. Okay, I actually selected a very small machine. Because of this, things are going very slow. It is T2 dot small. T2 small is very slow. Okay. Okay, let's wait for some time for this to complete. So our steps are very much clear. We can actually try our side also. So what steps we have followed in the previous session, the same steps we will be following. Um, so we'll execute package.sh and we'll install these are the steps to actually install the prerequisite. Then these are the steps to install Ansible. This is the steps to actually activate virtual environment, and afterwards Boto 3, those packages to install. This is the command, and then this is the steps to actually configure your AWS. And then this is a step to actually, as I actually explained you, this is a step to actually create master node and a worker node for Kubernetes cluster. So these are the steps to actually create master node, a worker node, and a private public key which can be shared. Okay. And afterwards, these are the steps to actually I'll explain you one by one. So this step basically is to create a inventory file. So we are trying to automate everything. No, there is no manual steps. So to create inventory file, host file, so we have written a simple script. So this is ec2k8.py. Okay, so this code is already there here. You can actually see it's a Python code actually. Okay, so this Python code will what it will do is like uh, it contains wait a minute. Yeah, so this, from here the code starts. These are all comments actually. So from here the code starts. Is this the correct one? Sorry, so it's easy to k8.py, right? So easy to k8.py. So this one. Yeah. So this is a very simple code. You can try to explain what we are trying to do is like we are trying to extract the IP address of the newly created EC2. So we have created one master machine, VM machine, and a worker VM machine, right? So we are trying to extract the IP address of that particular VM machine. So this is the code to actually get the IP address host information. So it will just loop through all the EC2 instances and try to append the IP address, private IP address into this particular host array. Okay. So all it does is like it will actually create a host array for you, host array for workers and host array for master. So this particular line will actually create a host array for master, and this will create host array for worker. And afterwards, we'll create a separate host INA file, host INA file uh, kind of environment. This is the syntax how it looks like, and master group that is coming from here, and the worker group that's coming from here will be populated. Okay, so this will be populated, and that output will be used as inventory file. So with the -i option. So if you go to the README here, so hi, finally what we are doing is like we are running Ansible ad hoc command where we are sending -i, which is inventory. To this we are sending the py file output, which will give you the host file or input. And from this we are trying to grab the IP address, and the IP address we are attaching it to the a file, newly created file called hosts. So that's what we are doing here. Similarly, master IP address, we are trying to get it and we are appending it in hash. So at the end of the day, we are doing a simple host file. We are creating a simple host file. And that host file, we are trying to use it here. This particular code is only meant to automate distribution of SSH key between the newly created machines. Okay, so if you open this particular distributed key.yml, so if you remember this command is nothing but simply copying that particular public key called, we are trying to log in using DevOps key, and using the DevOps key login and copy the public key to the list of authorized keys. It is as simple as that. This single line command, which we can just execute in a terminal. We can execute this particular command in the terminal. Instead, uh, we have created a separate playbook for it. So distribute key, all it will do is like it will copy the public key. So if you actually recollect the previous session, what we have done in the previous session, we have created multiple machines and we have actually copied those keys, those public keys into authorized key list, right, of the machine. Same thing we are doing here, but in a playbook way. So we are creating a separate playbook. So that is what we are doing. So we can just follow those steps. Okay, so M update is done. Okay, so now we can just follow the steps now, and I can just install everything. Um, so let's see if Git is available. Git is not there. So let's install Git. So we can install Git. Okay. Okay. So now we have installed Git. We can just install package dot. No, no. We have to clone the repository. Okay. Now we have cloned the repository. We'll get inside this repository, and you know the steps, right? Afterwards. So we just need to activate our Ansible environment. Ansible environment is activated by source command source Ansible. Command, we'll execute packages command. Okay, it executed an packages command, and now we need to install. Okay, so it's a bit outdated. This particular command is no longer there. I think we can just remove it. What is before that? Let me just verify. Let me verify if everything went fine other than this. Okay, so this is not working. This one thing is not working. We'll just ignore this. We'll try to execute the next steps. Okay. So before that, we can actually configure AWS also. So to configure AWS, we have to install AWS CLI. So we did in the last step. So we are doing the same steps again and again, but we get the point, right? So unzip does unzip work? Yeah, unzip is work fine. So okay, AWS is configured. Now we have to install Ansible. We will install other things. Okay, so we'll install Ansible now. We will create a Ansible virtual environment. We will activate the virtual environment, and then we'll do a pip upgrade. Install Boto. Okay, so we are already installing Boto here, so we need not execute the requirement.txt, which was done later. So this one will install Ansible. Okay. Okay, so this Ansible installation is a big file, so it will take some time. So these steps we already followed. So just to actually recreate the environment again, I have to execute the steps again. But the main steps are next actually, not these are not the next main important steps. This is just installation of Ansible. After that, what we are doing is important. Okay. So like here we are so like for example, this one, create infra is important step. So this one we actually creating one master machine and one worker machine. So that's what we are doing to try to understand. If you don't have time, we'll try to skip, but I would actually encourage you to execute all the steps. And if you remember Flask app, we had a challenge of installing Docker that is not working. So probably you can actually try to make the installation of Docker working. So yeah, so actually we can actually when we actually go to Kubernetes, right? When we discuss about Kubernetes, we'll revisit all these things again. So here we are actually demoing how we can deploy and configure Kubernetes using Ansible. That's what. So same thing we can actually discuss while we are doing discussion on Kubernetes also. So that's okay. I think we are good to and discuss it theoretically for now, and later we can actually execute one by one so that we understand the Kubernetes concept also and Ansible together. So that's I think that's a good move. For now, I will try to explain what we are trying to achieve right now. We'll try to cover as much as possible. I think we will use our time better. We will switch to Terraform. Terraform is a very important topic, and that's very interesting topic actually. So we'll do hands-on on Terraform also. Before that, let me try to just execute till at least till this step, create infra. Okay. So let me configure AWS configure. We can just configure like this. Uh, okay, now what did I did install Ansible. Okay, now Ansible installation, like previous session, I have installed Ansible now. After installing Ansible, um, AWS configure. Okay, so I'll just configure it. Mhm. Okay, default region AP South, Mumbai, right? Mumbai AP South 1 is the default region for me. Okay, output I will put something. Now, now AWS configure is done. So let me actually execute to the main part actually. So now everything is done. Let me just check uh, create infra code. Shall I modify something? Okay, this one definitely I have to modify. Our key is new bastion, right? New bastion.pm. So that's what I have to change to. So I have to change create infra.yml. I have explained to what is create via ML. It actually creates one master and one worker. Okay, so I will just get this done. So my new file is new bastion. So this is a new key I have created just now. Okay, and I want to create instant type T2 micro and image ID. Let me confirm what image ID I want actually. So let me go to my EC instance. The image ID I will AMI ID. Sorry, AMI ID. I'll get it somewhere here only. Yeah. So this is my AMI ID. Let me copy this. So by this AMI ID, I'm creating a CentOS based AMI ID. So CentOS 7 based. Somebody actually commented saying this for CentOS AMI ID. You can use this. But I'll try to use this only. Uh, I'll try to use this. Bracket is not required. Okay, so my reason is also not EU, it is AP South, Mumbai, AP dash South dash one. And the subnet mask also, shall I modify? Yeah, subnet mask. This is simpler. I'll use subnet mask. Okay, I use this subnet mask. bit mask. So let me go through the entire code. So here I'm going to create SSH keygen, and EC2, I am actually creating a new key called DevOps from the new ID RSA that I'm creating from the SSH keygen. Okay, that's cool. Now master, I'm trying to count is equal to one master I'm creating with this key pair as for authentication. Okay, everything looks cool. I think I'm good to go now. So that's it, right? So this code, try to understand. This is to create master and this is to create worker. That's it. Yeah. So now I'll just execute it. Ansible playbook. Okay, I have to just look into just for demo purpose. I just follow readme.md so that the code is exactly in sync. I hope everything should go fine. Yeah, looks like it is launching properly. Now you can see that we can actually monitor it from here. So I was actually going to cover Grafana and Prometheus today. So this is Grafana dashboard actually. So Grafana dashboard actually we can actually create in a AWS instance also. And in this case, I have created a Grafana instance in my local machine. It's a simple Docker machine. You can just download it from Docker Hub and just run it. So this is what I did. And I have configured it with the EC2 instances. So this also I can quickly explain actually. So it's already configured, so you can understand this. So I have configured my Grafana instance with CloudWatch. So this is what CloudWatch is. So I have configured with CloudWatch, and I have mentioned a few attributes here, and the instance ID it was polled instance. So because of that, there is no data coming. So now newly created instances will be there, right? Those instances I can just add it to monitor actually. So probably that is good way. I can explain you Grafana also parallelly. Um, Let me see if everything is going fine. Yeah. So you see, right, by running one YAML, I have created for Kubernetes, I have created a master machine and I have created a worker machine. So these two machines I have created, and you can verify that the key that is being used should be something else. So let's see for now. Keep it. So you remember we didn't have these keypads. We had new Bastion, only Bastion only. DevOps was not there. So by running the playbook, I was able to create a new key pair in the EC2 instance, which can be reused later. So I have created a DevOps key pair also. So I have created two instances, master instance and the worker instance. Two worker instances I have created, and one key pair also I have created. I am using that particular key pair, DevOps, to map to this one actually. Yeah. So okay, fine. Now you understood, right? So how we can actually create master and worker, right? So probably we can go to next steps. We can actually just follow these instructions and run other steps as well. Um, so this one will actually uh, should actually work. Create info after this, but I have to verify with the new key frame. Actually, I have to verify ec2k.py. Let's see, because I have created a new Bastion key, right? Now that new Bastion key, is it that ec2k8.py? So yeah, so here user also should change. Yeah, here it is Ubuntu. I have to use CentOS because I'm creating a CentOS machine. Okay. Now I can just run this particular POI file like this. EC2 dot EC2 dash K8 dot PY. Okay, so it was some problem. I forgot to add closing apostrophe. So this is a good case, right? You can actually test the syntax of it, like Ansible, Ansible playbook and EC2. Oh, sorry, it's Python file. It's not a playbook. So, and so if there is a syntax error in the playbook, we can actually test by the command syntax check. So there is something called syntax check. There are different attributes, right? Syntax check actually checks the syntax of the YML playbook. Actually, list tasks actually lists all the tasks that are going to be executed from the playbook. List hosts actually lists all the hosts that are going to be getting affected by run after running the playbook. Check will actually check whether that playbook is the execution of the playbook will work fine or not. Syntax check is only for syntax check, like that. Okay, so we can run different way. Let's edit this. Let's edit this particular file. So this particular Python file is going to create an inventory for you. Uh, so there is the syntax error here. Closing apostrophe was not there. So if I just run, we can just run this Python file like this. Oh, and some more, and line number 33. I think what is the error? Print JSON terms. Invalid syntax. No, it is correct only. I think uh, hmm. Okay, so the closing bracket, I deleted the closing bracket. Looks like there was a closing bracket before. After Ubuntu. So Python 60 follows indentation. So we have to follow the indentation correctly. Hope this works. Yeah, should be very careful while writing indentation in Python. Cool. So this Python actually created a inventory file, something like this. Okay. So you can see that we can actually extract the private IP address 172.31.44.10 for the master. The master private IP address is this one, and the worker private IP address you can see. The worker private IP address is 194. You can just verify it. You can actually verify it from the EC2 instance here. From private IP address is 194, so which is matching with here. The Python file is able to extract the IP addresses. Now let's see if everything goes fine, then we should be able to create host file also. All we need, everything we need to understand, the entire code is having a proper README. So we just need to follow the steps and try to understand the code. So try to understand this code. What we are trying to do is like we are trying to extract the IP address and putting it in the host file. Okay, so hopefully there is no syntax error here again. If there is, then uh, we need to again execute. So
Anil,
yeah,
one
yeah,
clarification.
yeah.
So master and worker is like production and development like that. Can we consider, or it's different?
No, 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 no. So this is a Kubernetes master and Kubernetes cluster that we are trying to create. Okay.
No, it's
So
similar like this or
okay,
concept. I'm
let
like
yeah, concept only. Concept it is not a production environment. Both are in production environment only. So
oh,
let us please say you Kubernetes master and worker.
or it's a node kind of thing. Like can we say
Yeah, they are nodes. They are actually nodes. There can be
like we have
multiple.
a GitHub master branch and
No, no,
like
no, no, no,
that
no, no, no.
node will be there, no? Like that.
Master branch is different actually. See, so let me explain you this diagram. Node in Kubernetes, they use different terms, Shankar, actually. So
Okay.
node is you can say node is can be a virtual machine or can be a separate laptop machine or a separate blue
Correct.
metal machine and so on. Okay. So
Okay.
in Kubernetes, node is an independent machine. It is an independent machine which has its own operating system, everything. Okay,
Okay.
it's an independent machine. It can be virtual machine. It can be a physical machine. It can be a big blue.
Individual
It can
desktop also. Yeah.
individual desktop also. Okay, yeah. So node. So this is node actually. Okay. So uh, Kubernetes main idea is to deploy and maintain, monitor all the applications which are deployed in many nodes. Okay. So what we say is like we give some 100 machines to 50 machines to Kubernetes. Okay.
Okay.
So to yeah. So imagine that Kubernetes is a very clever tool. Uh, all you need to do is like give a set of machines to the Kubernetes. Okay. You give like 50 machines to Kubernetes, saying that okay, these are the 50 machines I am giving you to you, and you need to maintain. You need to deploy applications whether it is a Python application or whether it is a React based application or it can be a Java based application or it can be a .NET based application. So all whatever applications, also I will give it to Kubernetes. I will say that, hello Kubernetes, I am giving this application to you. I am giving this C# application to you. And you need to create two, two C# applications in some machines of your own. Okay, I don't care where you create. I don't care, but you have to create two C# applications, three Python applications, and two React based web front end application. Like that, I will just say it to Kubernetes. Okay, you got it right?
Okay.
Yeah,
Yeah.
I will just
So
I
in
will
the
just
same machine or it's in a different machine we are giving
that
this instruction.
that Kubernetes will handle. I don't have control on it at all. I will
Okay.
say I will just give Kubernetes is very intelligent. I will say that I am giving you a C# application. The C# application actually needs minimum of 4 GB RAM. I will say this to Kubernetes. I will say everything to Kubernetes. It needs minimum 4 GB RAM, 4 GB RAM, 100 GB hard disk, and some CPU speed. I will see everything to Kubernetes, and it is responsibility of Kubernetes in searching. It will search in all available 50 nodes. Which node is containing minimum 4 GB RAM, 100 GB hard disk, and in one particular node, it is all these configurations are requirements are matching or not. It will check by its own, and if that match happens, then it will run that particular C# application in that machine. Okay, that is what Kubernetes will do for you. So all you need to do is like give it some set of nodes. Well, those set of nodes are nothing but worker nodes. Okay, so that is what worker node is actually.
Okay.
Okay. So here I am talking about master node, worker node, right? So these 50 machines that I'm giving to Kubernetes is a set of worker nodes where our all our applications will be automatically deployed, monitored. If some application is hanging, it is getting down, Kubernetes will automatically handle that. It will again restart that particular application. It will again it will stop that application and bring it up, and so on. It will take care of everything. It will take care of. It will make sure that it is running 24 by 7. All it will do it for you. All you need to do is like via some YML, which is called deployment.yml, replica.yml. So via YML, we will inform Kubernetes about what applications we are going to run. That Kubernetes
Okay.
will
Do we
handle by
want
itself.
to give the instruction of the machines where and all it has to deploy?
Yes, those instructions we will give it to it. We will give it
Okay.
via a YML called deployment YML.
Oh,
It
okay.
is not
Okay.
only deployment.yml. There are many other things also. Okay, for our simplicity, we'll focus on only deployment.yml. Okay, in
Okay.
deployment.yml, whatever we have discussed, right? I will say that this one, the memory space, all these things, I will actually inform it in deployment.yml, and it will internally read understand that particular YML, and it will make sure that that application is running in proper node. In out of the 50 nodes that I am worker nodes that I'm giving, it will make sure that it will allocate this particular C# application in appropriate node with that minimal configuration that I am recommending. Okay.
Okay. So those
Yeah.
configuration recommendation will be in the YML file.
YML, that
YML file.
YML.
And
Yes.
also IP address it will be there, right? IP details of the machine.
No, IP details also
Oh,
will not be there. That
okay.
also Kubernetes will take care of it. I just need to give that YML to Kubernetes and I will just sleep. Kubernetes will handle everything.
But that instruction
Hmm.
where we will give actually those machine details.
Machine details, what we'll do is like while installing, now we are installing Kubernetes, right? Via Ansible. So there we will give the machine details. Now in this
Okay.
example, if you see, right, I have deployed one master machine, one node machine, one for example, this one what I did. But in real-time application, this will be not one worker node. There will be 50 worker nodes. Now I have created only one worker node. Uh, Similarly, I will create 50 worker nodes. Okay, this is here in this 50 worker nodes. Uh, one time I have to do setup such a way that I will say Kubernetes. I will install Kubernetes specific software in the master. This is master. In real industry, what will happen is like there will be minimum three masters will be there because Kubernetes itself may get down, right? Kubernetes is also a software. It may also get crashed. It may also get down, right? So for that purpose, the controller, which is the Kubernetes itself, it will be deployed in three master machines in normal. Okay, so
Okay.
so three master machines will deploy where the real Kubernetes software, who will actually handle everything, will be there. Okay, so that is called Kubernetes control plane. That is called Kubernetes control plane. Internally, the functionalities will discuss about Kubernetes control plane later. For now, what we'll say that Kubernetes master is the main controller. Okay, there will be minimum of three Kubernetes masters. We will configure the Kubernetes as a masters, and then we will add as many worker nodes as possible, and we'll say to the masters saying that okay, I am adding this node as a worker. I am adding another node as a worker. In this case, what I did is like I just created a worker node. This is one worker node I have created. If you see this one, this is a worker node I have created. After this is created, somehow I have to say to the master that okay, this is the worker node. Please take it as your worker node and install whatever software I'm going to say later tomorrow. Whatever application I will say to you, you have to install it in that particular in any worker node in under your control, and you have to monitor it. That's what we are saying. So that is what we are trying to explain it here. So this particular code is there, Armored Ansible AWS code, right? These steps, everything explain everything about it. So here, if you see, we are just in the beginning. We are just created two machines, that is master machine and worker machine. After that, we will configure the SSH keys, how they will connect with each other. This is the configuring the SSH key. After configuring the SSH key, we'll just make sure that everything is fine. Okay, just we'll ping and see that the master node is fine, worker node is fine. In reality, there will be multiple master nodes. There will be 3 master nodes minimum, and worker nodes as many as per our requirement. There will be there. We'll just check whether the master and worker are working fine or not. After that, after that, what we'll do, we'll configure the master. This is the code to which will actually configure the master. Okay. This is the code which actually configures the basic prerequisites for a Kubernetes cluster uh, to happen. Okay, so this particular code contains all software, minimum software required for a Kubernetes machine to bring up. So, like for Docker, Kubernetes internally uses Docker. Okay, so we will have Docker or any other container, any other container also we can install. But in general practice, nowadays we are using Docker. Okay, so Docker will install, kubeadmin will install, all those things. You can just go and open this particular YML, and you will see that all prerequisites which are required for each and every machine in the Kubernetes, what are required, that will install here. And after that, we will install all the software in the master machines, or master specific softwares we will install here. Okay, so this is the code which installs all master specific software. And after master is installed, we'll check that master is up and running. Okay, so this is what master, this is end of master. Now master is ready. Once after these 14 steps happens, master is ready. After the master is ready, now you have to add workers, right? You have to add as many workers as possible. So that you can do via something called discovery token. Okay, that master will give you one token. Okay, so that token, whatever token that gives you, that token you can use to add as many nodes as possible. So suppose you have 50 nodes, all you can actually add using this particular discovery token. So that is a simple way. Okay, just one line. After adding this token, like this, each and every worker node will be added into the Kubernetes cluster. As soon as Kubernetes, that means what happens is like the master will know what nodes are there under its control. Okay, by line number 16, master nodes will exactly know all the information of what nodes are there under its control. Basically, it knows all the IP address. Okay, so suppose there are 50 worker nodes. Each and every worker node basically has its own IP address, right? So master will have complete control on all the worker nodes via IP address. So once it has all the IP address, all the nodes under its control, it can deploy any application on its own. So in this particular example, what we are doing is we are creating a new deployment. So this is flags app.yml. This is a Python based web application that we are creating. Okay, one web application we are creating, and we are saying it to the Kubernetes master via a command called kubectl. We are saying that, okay, I want to deploy a particular Python based application under your control. You take care of it. You have to take care of it. You have to install it in some of the worker nodes. That is your task. So that is what you are doing by this particular command. This command will do that. So you can just quickly look into this particular flash.yml. It will be a simple deployment command. Okay, so if you see, open flask-app.yml. So this is the simple syntax. Like it's a deployment.yml. You can identify that by the keyword kind deployment. By the keyword kind deployment, you say that this is a deployment YML. And what are you deploying? I am deploying a metadata called flask dep. Flask deploy. I'm just giving it a name, flask dep. So what are the contents of this particular flask dep? The contents of this particular flask dep will be there in the specification. Here I say that I need replicas is equal to 2. That means I say that I need 2 Flask applications. That application, Flask application, my Python based Flask application, what I am going to deploy, the number of Flask applications should be 2. So that's what I'm saying by this keyword 2. Okay, and where I need to deploy will be actually like this is the what is the exact code. So this is like a Docker command, right? You know, Docker Hub, right? from Docker Hub, there is a Docker image, which is basically a Flask application, Flask-based application, and its name is Flask. I'm going to name it as Flask container, and it will be deployed. And there will be two deployments of this particular container because I have given replica is equal to 2. So that's what I am doing. So this is a simple example of a Flask container, and I am exposing this particular container in a port called 480. So this is, so finally what you can actually estimate that this is a simple uh, deployment YML that you are giving, deployment command, like I want to deploy a particular application, and this application is a Flask application, which is there in Docker Hub, and I want to make it two containers. Actually, every time it is Kubernetes responsibility to make sure that there are two Flask applications always running. So that's what. So that's what they say. So in Kubernetes, they say that this machines, to the machines we call it as nodes. Okay, and the application basically which we are going to run, that we call it as pods. Okay, so basically I am trying to run two pods. I will run two pods because I said replica is equal to 2. I will run two pods, which are basically Flask application. So it is as simple as that. And that I am going to say by a simple command, kubectl apply. So that is the command I'm going to give. So by running this particular command, kubectl apply flask-app.yml, I am deploying a Python-based Flask application. That's it. So now it is Kubernetes responsibility to internally make sure that this Flask application is running, and there are two Flask applications running, and where it is running, it is its choice. Sometimes we can hard codedly say that only deploy in this particular node only, but generally we don't do that. We just give you can see in this flash.application, you don't mention the IP address of any machine at all, right? So that Kubernetes master will take care of everything out of the 50 nodes which we have attached via discovery token, whatever nodes we have attached, right? So Kubernetes has control of all those 50 machines. So Kubernetes will have its own algorithm to identify which particular node is free, and it will just deploy this particular Flask application in that particular node. That's it. So if you actually run this particular thing, that you can actually find out. So we will actually run this entire thing once we actually visit the Kubernetes. Okay. So I think it is clear, little bit clear to you, right? Shankar, it is clear to you, right?
Yeah, yes, sir.
Okay, Shankar. So we will actually go through this all one by one, and when we actually visit Kubernetes, right, it makes sense. So next session we will actually run all these commands when we'll discuss Kubernetes again, and make sure that we understand the concepts of Kubernetes along with Ansible also. So in this case, what we are doing, we are taking help of Ansible to create machines. After the machines are created, we are taking care of Ansible to actually find out the discovery token, attach the master with the workers. So attach of master with workers, everything happens via this one, discovery token add on playbook. So using this one. So this particular add node playbook, run add node playbook, it will add all the workers to the Kubernetes clusters, individual masters. In this, our example, we will add only one node. But in real time, there can be 50 nodes, there can be 100 nodes, as many nodes as possible. Okay. Okay, great. Now we have this basic understanding of how the Ansible can be run. So we can just run this README. If you have time, you can try to run on your own. But next time when we actually visit Kubernetes, we will run this again, once again. Okay. So we will take one 2-3 minutes back. Okay, 5 minutes. I'll come back by 10:18, and we will start Terraform. Okay.
Okay, Anil.
Okay. Okay. Welcome back. So so parallelly, actually, I wanted to explain you about monitoring tools like Prometheus and Grafana. So I'll just give a quick glance of how actually we can actually run Grafana. So I just don't want to go with the installation of Grafana, how we can install Grafana in EC2 instances. So there, those steps are pretty straightforward. We can actually follow the steps anywhere by looking into the Grafana website also. Okay, so just wanted to cover them. Um, Basically, uh, let's quickly cover, and later we'll also cover most important topic, the Terraform. Terraform is a very simple tool and very powerful tool. We can maintain the entire infrastructure uh, using Terraform by a simple declarative syntax of YML. That's it. And we can configure the entire cluster, the entire cloud. We can create S3 instances. We can actually create VM instances, EC2 instances. So lot of things. We can do lot of things using Terraform. The only drawback that you need to remember in Terraform, once you move to Terraform, once you start configuring everything using Terraform, it is risky to manually change it. If you manually change the Terraform, then uh, uh, it will be going out of Terraform control actually. So that is the only thing that we need to take care of when we are using Terraform to manage our infrastructure. Okay, so let's go to monitoring tools, our 17th topic. So here we just wanted to discuss about Grafana and Prometheus, right? So we will instead of going to installation steps and everything, we'll have a quick overview of what Prometheus and Grafana is. Okay, and we'll next in the next session also we will try to discuss more about Prometheus and Grafana along with other things. Okay, so we'll just introduce ourselves to make ourselves comfortable and see that how easy is it. It is not at all difficult. Once you need to have some time to learn the tool. That's it, and you need to spend some time how to configure it. Otherwise, it's not difficult at all. Okay, so like I have created a Docker instance uh, here. So long back I have been running. So you can just see, like we know Docker instance, right? I just downloaded Docker Grafana instance, and you can see here. So Docker PS, you can see Docker PS. Here you can see that I have downloaded a particular Grafana instance, which is by default running on port number 3000. In port number 3000, I am using Grafana 37.3.7. This is what the Docker Hub image is from. So you can actually go to the Docker Hub website. Okay. So just go to the Docker Hub go to the Docker Hub website and just search for Grafana and you will get the Docker image there. Okay, this is what Grafana is about. I think we already did it long back. So it's like just running this particular command. And in your machine, your Grafana dashboard should be up and running. So by just doing that, I was able to run my Grafana instance. This is my Grafana instance. And here I have to follow for some few steps. By default, remember, Grafana has a login username password. By default, it has username admin, password admin. That's it. So you just log into Grafana using admin. Immediately, it will prompt you for changing the password. So you can enter your password of your own. Later, next time when you are actually login, you can log in using admin and the password that you have reset. So I am already logged into Grafana. This is my Grafana instance. Okay. Now, uh, so I can actually configure Grafana. Grafana is basically a UI dashboard. Okay, so you can actually create your own UI based experience, and you can change the experience whatever of your interest is. Like this is what isolation looks like. Let me do what let me quickly explain you here. So I am trying to attach Grafana with CloudWatch. CloudWatch is basically a EC2 service which provides you different metrics. It gives you different metrics, like CPU utilization is one of the metrics. There are a lot of metrics that actually uh, a particular service like CloudWatch can provide you. CPU usage, disk space usage, your API calls, number of requests, direct free disk available disk space used, many things, right? Memory usage, free memory, allocated memory, um, and many things are there. You can use any of them. So Grafana provides you a fine way of adding your metrics. So this is metrics name. So you can just select any one of the metrics, right? So this is the metrics name uh, that you can actually opt for. So here I have used a data source. I have used data source as CloudWatch as a data source, and I have mentioned that it is belonging to region AP South, and I am going to watch CloudWatch only EC2 instances. Okay, this is only one example. You can do a lot of stuff. EC2 instances, and the metrics that I'm following is CPU utilization, and stats that I'm going to use is maximum and average. So here you can see average and maximum, and I am going to what resource I'm going to use is instance ID. So basically the EC2 instance ID. Okay, so now let's go and see what instance ID I can add. Okay, so here you see that EC2 instance ID here. This is instance ID. FF3. Remember FF3 or 093. Okay, so this instance ID you can actually add into Grafana. So you can just go here and you can search for FF3. So this is FF3, right? So I'm just adding this FF3. So as soon as I add FF3, I get the statistics of FF3 instance. I can just add another also. Uh, okay. So let's stick to this one, right? Now, CPU utilization, CPU average and the CPU maximum I'm going to get because I have found the stats maximum and average, right? So this is what I can actually change the UI as per my needs. Here you can see you can play with it. Utilization is one tab. So instead of this number, I will want to bar graph. So this is bar graph. I can see the bar graph like this. I can, instead of that, I want to see like this. Instead of that, I want to see like a gauge. So this is the gauge way. So you can just play with as per your requirement. So you just need to spend time. What is the best way you can actually show your UI, right? So you can convert all your metrics. In this case, I'm using CloudWatch. You can add anything else. Okay. So this is a simple example, right? I have given you how to add graph. This is a uh, I just explained you in the middle. From the scratch, or how I can explain is like after login, you can add a dashboard of your own. So somewhere here you will see dashboard. Yeah, so this is dashboard. Okay. So dashboards, go to dashboard. Save your change. Okay, I'll discard. I don't want. I'm discarding it. So in dashboard, you can just go to dashboard. You can just go to dashboard. You can create your own dashboard. I have created a dashboard called EC2, right? So similarly, you can create another dashboard here. And in the dashboard, you can create a new panel. In this panel, you come back to the same place, right here. So in the complex, what are you going to connect? So I have shown you an example of CloudWatch. You can add primitives also. So primitives should be configured. I have already configured for our CloudWatch, so I'm using it. So similarly, you can enter any other data source also. So, so this is what, right? You have seen the UI. From here, I already explained you. You can just play with. So this is a quick glance of how you can use Grafana and attach your data sources. In this example, I have shown AWS CloudWatch data source and how can you view uh, the statistics of different metrics that you configure here as a dashboard here, as a panel output here. Statistics you can see here. So Grafana is very flexible way. I just explained you the basics, right? So you can actually play with lot of things actually. Lot of things you can actually play with it. Um, so this is a brief overview of Grafana. So if time permits, I will go on. I will probably discuss more about Grafana in the later talks. Now let's come to other topic actually. uh, Terraform. Okay, Terraform. So this is also like just to make us comfortable that Terraform is so easy. I will just explain you quickly about Terraform also. Okay, Terraform is basically infrastructure as service. Okay, so we can actually configure our infrastructure so simply using Terraform. We just need to download the binaries of Terraform in our machine and just run a few commands. Terraform init, Terraform plan, Terraform apply. Only three commands. So if we run those commands, then we know those commands. We are good to configure of Terraform. So I'll just quickly explain you how Terraform can be configured and run. So let's go to Terraform one now. Mm. Yeah, so if we understand the basics, right, then we'll be confident enough to jump more and more deeper into Terraform. Okay, so within few minutes we can actually configure our Terraform. I'll show you how easy it is to configure the Terraform. So basically, Terraform is the infrastructure as code, right? It's a very powerful tool, and it is integrable with all cloud applications and whatever you name. So it is integrated with everyone, and it is actually product of HashiCorp. Okay, HashiCorp. Just it's a very important company. As a DevOps engineer, we need to know about this particular company. HashiCorp has a lot of products, and each and every product is a cream. It has come with a very beautiful products. Vault, we or Terraform and Vagrant. So these actually I have personally used Vault, Terraform, and Vagrant, and they are in fact used in every industry. Every big industries they are using it. Okay, and others also might be very famous. They might be very famous. I haven't used it personally, but they might be famous. So let's focus on Terraform only. So okay, so Terraform, if you go right, so they have support for everything. They have support for AWS. They have support for whatever cloud solutions you have. You can name it and you will get it. So you can just go to registry Terraform and learn what we can do in Terraform. Okay, Terraform registry. So here you can see all the cloud providers. The main cloud providers you can see here: AWS, Azure, Oracle, Kubernetes, Alibaba, GCP. There are many other providers. So you can just go to see all, and you can see other providers as well. Okay, so let's go to AWS provider, and you can go to here, to the documentation here. This is the documentation. From here in this documentation, it's like ocean. You can learn anything. Suppose in the documentation of AWS, EC2, AWS, you are interested in EC2 only, you can go to EC2. Okay. Here EC2, EC2, yeah. So we are in EC2. So from here you can actually go to the uh, specific uh, resource of your interest. Okay, so in Terraform, everything is resource. So EC2 instance, if you want to create a EC2 instance, you can modify EC2 instance, you can go and read the documentation of AWS instance, EC2 instance. So this is a typical example, simple example of how we can run Terraform example. And now we will actually try to run a simple Terraform code of creating EC2 instance. Okay, we'll just explain it. So that's we already have covered in our slideshow. Okay, we'll just go to that and try to jump into that place. Okay, we already have this machine, right? We can leverage this particular machine, Bastion. We will try to run our Terraform code there in our machine. Okay, now let's see what we can do quickly here using Terraform. Let's try to connect and run Terraform there. Okay, now, yeah. So I am trying to log into the machine, and my final goal is to run a simple Terraform, create an EC2 instance using Terraform. Okay, so I am inside the machine. Now I will just install a Terraform. How to install Terraform? We have create steps to actually install Terraform. Yeah, so these are the steps, right? So just log in as root. Mm, mhm, mhm. Log in as root. Now, is wget there? Wget is not there. So let me install wget. Okay, so wget aborted. Okay, wget installed. Now I'll just copy. So I just will have to copy a simple zip file. This is a zip file. Terraform has latest code, latest version. I'm actually downloading 0.12 version. It's okay for demo purpose. But copy didn't happen. Okay. So this downloaded the zip file and I need to unzip it. So I unzipped it. I need to just copy this to user local bin. Okay. So move command, move it to user local bin. Use move Terraform to slash user local bin. I moved it. Now that's it. Your Terraform is installed. It's as simple as that. So you can verify it by typing Terraform version. Okay. So it says that your Terraform is installed. Your version of Terraform is out of date. Okay. Anyway, but Terraform is installed. Your version is 0.12.28. Okay. Now let's do a simple Terraform run in Azure. So this is what I want to run now. So I am going to create a EC2 instance using Terraform. So let me show you how simple it is. Okay. All I need to create is, okay, Terraform is installed. Terraform is installed here. So I'm creating instance.tf. I'm just going to create instance.tf. Okay. And I'll just run this particular code. Okay. Let me not do it in EC2. I'm doing it in Mumbai region. I will do it in Mumbai region. Okay. And AMI, I hope it is working fine. But for surety, I'll just copy the AMI which is there available with me. This is the AMI already there. So I am going to create this AMI by using this AMI. What I'm doing is like I am going to create a CentOS machine. So this AMI you says that it is a CentOS machine. The CentOS image, I mean AMI is nothing but image, right? So I'm going to create a machine from a CentOS image. That's it. And I'm naming that machine Bastion. This is what I am saying, Bastion. I can give another name also. Okay. So maybe like I will say test machine. This is the name that I'm giving, and this is the resource. This is the resource that I'm giving. So I will explain you what is it. Before that, let's just let me try to run it. I'll just run it. for now. So your instance.tf is ready. All I need to is like Terraform init. This is the command I need to run. So Terraform init has initialized uh, by taking the TF file. Let me again open my TF file to just confirm everything is fine. I hope everything is fine. Only thing is like I am not at I haven't given the credentials, like AWS credentials I need to give somehow, right? So that is only missing. So the credentials I can give in numerous ways. One of the way is like AWS secret key and AWS access key. These two keys are already I have here. Somehow I have to give these two values. These two values I can actually give it in the Terraform file itself, or I can give it as an environment variable. How can I don't remember the environment variable correctly. That environment variable should be there. Maybe like I can just go to Terraform documentation. Mm, or it's there in the slideshow. I don't remember this exact syntax of the environment variable. Okay. Okay, so this one AWS credentials, I can give it like this. Okay. Okay, let me try this. So just log in and create a file called AWS. Okay, so already I have credentials here in this machine. So maybe it will work directly. I just need to have, I just need to run the command Terraform plan. Sorry, Terraform plan. Okay, so okay, so this is what the plan is like. It is actually saying that I am going to create a AWS instance with name test mac, and these are all the values. These are all the values. This is the device name. This is what for a block device this is meta option network interface. This is road plugins. This is actually informing you, saying that I am going to add one machine, one resource. Add. Nothing is going to change. Zero to destroy. I am okay with it. So I'll just apply Terraform apply. That's it. So I just apply it by this simple command. So what I did to do? Terraform init, Terraform plan, Terraform apply. It is asking for confirmation. Yes, I will type yes. I want to create. So I just creating a Terraform. So just one command, Terraform apply, and it is just creating a machine for me. Done. So we have successfully created a machine for us. So it is as simple as that. So you can just verify it here. So before there were only 3 machines. I'll refresh this now. See, so this is the fourth machine automatically created. It is still initializing, and by writing a simple code. So the code what I have written is a very simple code called instance.tf. So this particular simple code I have written, and it just created a instance for me. It is very simple, right? So this is a brief introduction of Terraform. So we can actually explain what happened in details, right? So in Terraform, right? Always remember in Terraform there is a provider that needs to be mentioned. Provider. Okay. So we have mentioned provider. There are many providers as we have seen. In this case, we are mentioning that AWS is a provider that we are going to use. We are going to use AWS provider, and we are giving the details about to the AWS. We are going to use version 2.0 onwards, and we are going to use the region AP South, AP South, which is Mumbai region. We are going to use the region Mumbai South. Now, what are we going to do with this particular? What are we going to do? What is infrastructure we are going to build? We are going to build a particular resource. What is the resource? The resource is of type as a AWS instance. Okay, I am going to create a AWS instance, and the name of the instance that I'm going to create is test mac, and I'm going to create an instance from the image with name AMI 0e dash dash. Okay, and I want to create an instance type of T2 micro. So that's what I'm saying. So by this particular command, and once I did do that, what I did is I applied Terraform init. So by doing Terraform init, what it will do is it will initialize your project. It is like initializing your infrastructure project. Okay. So by doing Terraform init, it is initialize everything. It is looking into this particular TF file. From this TF file, what is required? It is required to download some particular plugin called AWS, because you have said that your provider is AWS, right? In TF file, you have mentioned that the provider is AWS. So it will try to download this particular plugin for the provider AWS. It downloaded the plugin from HashiCorp. So that's what you mentioned. It is downloading from the registry. That's what you mentioned, right? So this is the registry. So if you see in the registry top, it is downloading this plugin, AWS plugin. Okay. Now, after downloading the plugin, it says that, or maybe like because the version is outdated, right? The version I have used is old version. It's okay, and it says that it is successfully initialized your Terraform project, and you can start working on it. It already gives you a hint. You need not remember the command. It says that you can just start with Terraform plan. You can look into the plan. Okay. Now after this, you just have to run the Terraform plan. So what does Terraform plan do? It will just run this particular TF, and it will show you the output. What will be your infrastructure look like? It will give you that particular plan. So that plan it will give you here. Okay. So this is all about the Terraform plan output. So you can actually look into it. You can look into each and every values here. In this case, we have written a simple Terraform infrastructure project, which is actually creating a instance. We didn't mention all the other like network card, hard disk space, what block storage we need. We didn't give. So it took some defaults, and it is saying like, so these are all the values you will do. I don't know for values which it does know. It will says that only after apply I will know those values. Okay. So it is giving all the information like availability zone, CPU core count, CPU threads per core, get password, lot of other information. It's going to give information about everything. These are all the values. So this is about the plan. So also it mentions that one resource is going to be added, and you have to use minus out parameter. It is actually noting you didn't give an dot out parameter, and that out parameter will be used can be used offline to actually investigate and see if it is okay for you to actually continue to apply it. Okay. So after this you can just apply. But so in real time, what will you do is like while doing plan, right? Terraform plan, we will do Terraform plan dash out your output file. Okay. So that's what you actually do. So instead of Terraform plan, you say Terraform plan dash out dot dash out and your plan. Maybe like you can say plan dot out. So by typing this Terraform plan, all your plan will be there in the plan dot out. So the plan dot out will be created. and that plan you can actually apply. Now you said Terraform apply, right? Here, instead of Terraform apply, you can say Terraform apply plan.out. So you can say Terraform apply plan.out. This is what you can say. Because Terraform is basically idempotent, you can safely run the apply again and again. And it will say that already applied and nothing is to change. So here you can say that apply completed and nothing got changed. It zero added, zero changed, and zero destroyed because already it has executed once, right? So once it has executed, it showed you that one added, zero changed, and zero destroyed, right? So second time if you apply again, it will not add anything. It will just say zero added, zero changed, and zero displayed. You can actually do the same code again and again, and it will run again. And this time it actually warned you saying that the plan is already outdated. So game plan can no longer be applied, right? Because you have already applied the plan, so it will not reapply and it will say start plan. So even if you say again, even if you say Terraform plan.out, if you say again, it will try to re-execute the plan. It will try to see what changes can be done, and it will again say that the of via if you do the apply change, it will again say that there is no change to be done. Zero added, zero changed, right? So basically Terraform creating infrastructure is involving three steps: Terraform init, Terraform plan, and Terraform apply. So these three commands will actually complete the complete infrastructure management, right? So this is a simple demo of how you can actually use Terraform. You have seen that the instance was also created here. And what else you can actually do? So we have different examples like how we can actually uh, use variables in Terraform, how we can use some functions in in Terraform functions. What are Terraform functions? How we can use that? We will look into it. Okay. So we have a project here. Uh, we can just refer to the Terraform project. It is a publicly available. You can actually try all this. So we have tried lab one right now. So just a simple instance.tf. This is what we have tried. We can try next steps. So this is the next project. Um, so it's like it's the same thing, but we have divided the code into two different files. So provider file, we are actually mentioning the AWS file. That's what we are mentioning here. And we are using variables here. So instead of creating the variables, we have hard coding the variables. We are creating a variable called var.aws key. Okay. So we will try to explain this, and we will try to execute this also. Do we have time? Yeah, we have time. Yeah. So this one also we can actually apply. Maybe like I will actually clone this particular code now right now itself. Where am I? Okay, I'm in root. Git works. Yeah, Git works. So let me clone. Okay, I cloned it. Now let's go to Terraform. Let's go to lab 2. Okay. So now I am in this lab 2 project. So in this lab 2 projects, I am trying to demo about variables. Okay. So this is about variables, right? So I have to use variables. So as I already shown you, this provider everything actually uses variable. So you can just run this particular Terraform. What is the commands to use the Terraform? Terraform init, then Terraform plan, right? So you can just initialize your project by typing Terraform init, and probably it is expecting some variables, right? So AWS access key, AWS secret key, and reason. Okay, so here reason is already having a default value. Default value. I don't want to use EC to EC to EW West. Let me change the default value. I will use, because the Mumbai region is nearby, I will use Mumbai region. Okay. Okay. Now let's see. EC2 has region as default value, but AWS key, AWS secret key are not initialized. They are only said that they are of type string, right? So what are the actual values, we don't know. So while running Terraform plan, let's use out for now. Mine's out. Plan dot out. Enter. Okay. Terraform plan. I have to say Terraform plan. Okay. Now because I see it doesn't know the variable values, it is directly asking me what is the value of AWS key. So I can just, it is asking me to enter the value dynamically. So I can just go and enter my AWS key value. Then next it is asking me for the secret. So I can go and enter the secret. So after entering it, it is as usual. It is going to show me the plan, and it is actually copying the plan in plan.out because I have already mentioned it as plan.out. It is copying in plan.out. Okay, I can actually see the plan by opening the plan.out also. Okay, I have to open it in a different editor. Okay, now I can actually apply it by specifically mentioning the Terraform plan by saying Terraform apply and plan.out is what I want to apply. Okay. Oh, okay. So AMI is wrong, right? I have to edit the AMI. So I have to mention the AMI. I have used the default AMI, which comes as a part of GitHub clone. So probably I just give the same AMI and it will work. So AMI is there uh, in EC2 TF. So here AMI, I will give. Okay. Okay, I have to, because I changed it, I have to create a plan again. Okay. So it is asking me for AWS key every time, right? So I have a better plan. So instead of doing this way, I can create a new file called Terraform dot Terraform dot tfvars. So I can actually mention my AWS access key like this. AWS and mention my, I can mention my key here. This way, it will not prompt me for AWS key because I'm already mentioning it. Okay. And AWS secret key. This is the other way. Let me check if it is equal to or not. I think it is. It is syntax correctly. It is correct syntax. Okay. So if you mention anything in TF vars, right, it will automatically take the variable values from here and it will not prompt for you. Okay. So now it prompted for me AWS dot key, right? Let's see now again by doing plan dot out. Okay, so it is saying complain that you should mention it as equal to. I should mention it as equal to. Okay, so let me edit it again. Okay, I think it will work. Now I'll plan. Okay, looks like it works. Yep. So now it didn't prompt me for the key variable names, right? Because I already mentioned the key value, right? Because I already mentioned the key value, it is actually didn't ask me for the key and secret. Now all I need to do is like again I have to apply Terraform apply plan dot out. It will just execute the plan for me. So you can just verify it here. It will actually create a new instance form. Now, what if you want to delete whatever you have created, right? You are creating a new machine right now. Okay. So this machine, you want to destroy it. So in order to destroy the machine that you have created using Terraform, you have to execute the command Terraform destroy. Okay. So machine is already created. You can use Terraform show to show the results. It is already giving you hint. And if you want to destroy your machine that you have created, you can just say Terraform destroy. So it is just confirming you. Yes. So it will just destroy the machine that you have created. So it destroyed it. It's done. Okay. So this is where you can actually remove the interfaces that you have created via plan. So successfully destroyed. So I just wanted to show you a few more things. Um, lab 01. Let's go to lab 01. So if you see ls, right? No, lab 01. Yeah. So if you see ls in this root, right, you will see that uh, not here. Yeah. So here you will see that when you execute a Terraform plan, there is something called Terraform state. Terraform state. So this will get automatically created as a part of Terraform when you actually execute the plan and then when you apply. So this state gets executed, and every time your Terraform code changes, right? And when you again execute the plan and execute apply, then the state will also automatically change, right? So here also you can actually apply Terraform destroy to destroy this particular new instance that you have created using Terraform. Oh, let's see the TF state, how it looks. So you can see like Terraform.tf state. So, okay, VI. So this is how the Terraform state looks like once we apply. Now after you again replan it, probably like you again apply Terraform destroy. Then you can see that your TF state, this Terraform state will also get changed. So by doing this Terraform destroy, it will actually remove whatever resources it has already created for you. Okay, let's confirm it, yes. So by this, it will actually delete it. Yeah, so it actually deleted again. Okay, so this is about for today. We have discussed, introduced Terraform. So we'll discuss more about Terraform in the next session, and probably again discuss about Prometheus and Grafana also. And most important thing is that we will try to introduce Kubernetes also. Yep. So yeah. Okay then. Thanks Shankar. Thanks Virvalan.
Yeah, thanks, Anil.
Thanks, Anil.
Okay. Thank you.